The light reaching you right now is older than almost anything you could name. It left its source when the universe was newborn, and it has been falling toward us ever since, for more than 13 billion years. It comes from a single galaxy, and by every rule we thought we understood, that galaxy should not exist. It is too bright. It is too grown up. It carries the chemical signatures of stars that should have needed billions of years to appear. The people who found it were so unsure of what they were seeing that they named their entire search after one question. Was this real? Or was it a trick of the light? This is the story of how one faint smudge of light began to unsettle everything we believed about how fast the universe grew up. To understand the problem, you have to understand what the early universe was supposed to be like. For its first stretch, the cosmos was a hot fog of hydrogen and helium. No stars, no galaxies, just gas, cooling in the dark. Cosmologists call this period the cosmic dark ages, and it was meant to last a long time. Slowly, gravity would pull that gas into clumps. The clumps would collapse. The first stars would ignite, and their light would burn through the fog until the universe finally turned clear. That transition has a name, too, the cosmic dawn. And for a long time, our best models agreed on roughly when the first real galaxies should appear, and on how faint and how small they should be when they did. Then we built a telescope large enough to look that far back, and the models began to break. Astronomers measure cosmic distance using something called redshift. As the universe expands, it stretches the light traveling across it, dragging that light toward the red end of the spectrum. The more stretched the light, the farther away its source, and the further back in time we are seeing it. High redshift means very old, very distant light, and this telescope kept finding galaxies at redshifts no one expected. Bright ones, big ones, galaxies from the first few 100 million years that were far more common and far more luminous than the models had ever predicted. Not by a little. The number of bright galaxies from that early era came in more than 100 times higher than the consensus said it should. One faint object sat right at the frontier of that impossible crowd. And to understand why it rattled the people who found it, we have to go back to the moment they first saw it. The team was led by an astronomer named Rohan Naidu, working at the Massachusetts Institute of Technology. And Naidu and his colleagues had a problem that sounds almost philosophical. They kept spotting these faint red dots buried in the deep images, objects that looked like they might be galaxies from the very edge of time. But looking like something and being something are not the same. At those distances, ordinary galaxies much closer to us can look almost exactly like ancient ones. A smudge that seems to sit at the dawn of everything might really be a nearer, dustier galaxy that only appears to be that far away. So the team did something that tells you exactly how uncertain they were. They built an entire survey around a single question they would ask of every candidate. Was it real, or was it a mirage? They called the survey, plainly, Mirage or Miracle. The name is almost a confession. These were serious scientists staring at objects that, if genuine, would be small miracles of the early universe, and they honestly did not know whether they were looking at a miracle or at their own instruments fooling them. To settle it, they turned the telescope on one of the most promising candidates and split its light apart, spreading it out into its separate colors so they could read the fingerprints written there. What came back was not a mirage. The light showed a sharp, unmistakable edge, exactly where you would expect for a galaxy whose light had been stretched by a factor of more than 15 on its long journey to us. They had their answer. The object was real, and it was sitting more than 13 billion years in the past, only about 280 million years after the universe began. They gave it a designation, MOM-Z14, and in the paper announcing it, they reached for one phrase to describe what they had found: a cosmic miracle. But confirming that it was real only sharpened the problem, because now they had to explain it. And the closer they looked at this one small galaxy, the stranger it became. Here is where the trouble really starts. Start with its size. This galaxy is astonishingly small. If you crossed our own galaxy, the Milky Way, you would travel about 100,000 light-years of stars. This early galaxy measures only a few hundred light-years across its bright core. It is hundreds of times smaller than the galaxy we live in. And yet, it is pouring out light. For something so compact, it is extraordinarily luminous, far brighter than our models say a galaxy that small, at that early moment, has any right to be. The obvious explanation would be a black hole. Many bright galaxies get their glow not from stars, but from a monster at the center. Astronomers call it an active galactic nucleus, a giant black hole feeding on gas and blazing with the energy of that violent meal. If this galaxy had one of those at its heart, the brightness would be simple to explain, and there would be no mystery. But when the astronomers studied the light, that is not what they found. The glow is not coming from a feeding black hole. It is coming from stars. This tiny, distant galaxy is simply packed with them, burning hot and young and blue, with almost no dust to dim them, which means the light is not a trick played by a black hole. It is real starlight from real stars, far more of them than should have had time to form. Then came the part that genuinely unsettled people. When the team read the chemistry written in that light, they found an unusual mix. The galaxy was rich in nitrogen compared to carbon, an odd balance that is uncommon in the universe at large. But it is not uncommon everywhere. We see almost exactly this signature in a particular kind of object much closer to home: globular clusters. These are dense, ancient balls of hundreds of thousands of stars, and they are among the oldest structures in our own galaxy. For a long time, we assumed they needed a great deal of cosmic time to form and to develop their peculiar chemistry. And here was a galaxy showing that same chemistry less than 300 million years after everything began. The implication is quietly staggering. The processes that built the oldest stars in our own Milky Way may have been running almost immediately. At the very dawn of the universe, we might be watching across 13 billion years the birth of the same kind of ancient stars we can still find in our own night sky. So the universe was not just making galaxies early. It was already doing the delicate chemical work we thought belonged to a much later age. It is a little like meeting a child, only days old, who already stands as tall as an adult. Not an impossible thing exactly. A thing that has arrived far too soon to make sense. So, how is any of this possible? This is where the science becomes a genuine argument, and it is worth being honest about that. There is no settled answer yet. There are several serious competing ideas, and the people who study this do not agree on which one is right. The first idea is that the early universe simply built stars far more efficiently than it does now. In those first few 100 million years, the cosmos was denser and more crowded. Gas that today would drift and resist collapse may have been packed tightly enough to turn into stars at a furious rate, wringing far more starlight out of the same material than any galaxy manages today. The second idea says the brightness is partly an illusion of timing. Star formation may have come in violent bursts, galaxies flaring up and dimming down again as waves of new stars ignited and died. If that is true, then when we scan the early sky, we naturally tend to catch the ones that happen to be flaring at their brightest, and we mistake that lucky snapshot for the normal state of things, we would not be seeing typical galaxies at all. We would be seeing the ones caught in mid-flare. The third idea is stranger. It suggests the very first stars were not built like the stars around us. They may have formed far more massive, each one enormous and blindingly bright, so that even a modest amount of gas could shine like something much larger. A galaxy would not need to be as heavy as it looks. It would just need to be lit by a different kind of star than any that survives today. And then there is the possibility that lingers behind all the others, that the problem is not with the galaxies at all, but with our fundamental picture of the young universe itself. That the ingredients of the cosmos, or the way matter first gathered under gravity, do not work quite the way our standard model assumes. Most scientists treat this as the last resort, the option you reach for only after the others have failed. But it stays on the table because whatever replaces it still has to explain what we are actually seeing. Here is what makes all of this far more than a puzzle about one strange object. This galaxy is not alone. That is the part that keeps astronomers awake. If it were a single freak, a lucky oddball, it could be set aside. But the telescope keeps finding them, bright galaxies from the first few 100 million years, again and again, far more often than the models allow. Remember that number from earlier, more than 100 times as many as the consensus predicted. This galaxy is not an exception to the pattern. It is the current record holder in a pattern that should not exist. And that forces a harder question than any single galaxy could. It asks whether our entire timeline for how quickly the universe grew up is wrong. Whether structure and light and even chemistry arrived not gradually across billions of patient years, but early and fast, and in a way we still cannot fully explain. So, what is the answer? After all of it, here is where the science actually stands. The leading view among most astronomers is both reassuring and humbling. These galaxies probably do not break the laws of physics. They are not proof that our understanding of the universe is fundamentally wrong. What they most likely reveal is that our models of how the first stars and galaxies formed in conditions we were never able to observe directly until now were simply too cautious. The universe in its opening act was more productive and more violent than we imagined, and we are being forced to rewrite that earliest chapter. But no one has proven which of the competing explanations is correct. A more efficient early universe, the flickering bursts of star birth, the enormous first stars, or something deeper still. We do not yet know. What we know is that a galaxy exists where our theories said the sky should still have been nearly empty, and that it is one of many, and that each new one we find pushes the mystery earlier and makes it sharper. This galaxy holds the record now. It will not hold it for long. There is something worth sitting with in all of this. We tend to imagine science as a settled thing, a stack of facts handed down and memorized. But this is what it actually looks like at the edge. A telescope sees something the textbooks said should not be there, and instead of hiding it or explaining it away, the people who found it hold it up and admit openly that they do not fully understand what they are looking at. They name their entire search after the chance that they might be wrong. That is not a weakness in the science. That is the science working exactly as it is supposed to. And the universe, it turns out, was busier at its beginning than we ever gave it credit for. It was making light, and stars, and even the delicate chemistry of the oldest suns, while the cosmos was still supposed to be nearly empty and dark. We built a machine to look back at the beginning of everything. And the beginning is not the quiet, slow place we thought it was. What do you think we will find when the record falls again?